Hello everyone and welcome. Let's model, assemble and animate a radial engine in Onshape. So I made this drawing here where you can see the parts, the crankcase, the crankshaft, the master rod, the piston, the connecting rod, and the cylinder. So let's start modeling. I'm in an empty part studio here. And let's start with a crankcase. So I start a sketch on the front plane, press N, normal view, P, hide all planes. And I take the polygon command, place the origin here and the origin. Make that 5 times. Radial engine always has to have an uneven number of cylinders. I make that line here with a horizontal constraint and give that circle a dimension of 166 and place one circle here with a 22 dimension, and then I'll make an offset of that circle to the inside with a value of 4 millimeters. Okay, that's it for the first sketch. I will extrude this here, that region with a value of 122 towards me. Then I'll place another sketch here on top. With you, I project all edges. I press N and I'll make those here with Q construction geometry, then another circle here with a 72 millimeter dimension and give that a vertical constraint. Oops. A vertical constraint between that point and that one. And I'll just draw a line from here to that midpoint, construction line, and make that a horizontal line. The sketch is fully defined. I exit that, go to the extrude, removing, and I'll just say up to next. I'll make a pattern of that last feature. Just click it here in the browser window. And that axis around here, well, it's going to be 5 times. And I make that sketch 1 visible again. Go to the extrude, adding to our part to the outside with a value of 8 millimeters. Like that sketch. Hey, what happened? Ah, yeah. Not only that face, but that one as well. So this is where in an airplane, the propeller would go, the shaft exits that hole here, okay? I will rename that part crankcase and give it some gray appearance. And I'll just apply a fillet 4 millimeters to these edges here. Okay. So I want to organize my work here, and I choose all those and add selection to folder and call that folder crankcase. Next, let's model the cylinder. I'll start a sketch for that on that plane. Project that circle, offset that to the outside with 4 millimeters, and offset that circle to the outside with another 14 millimeters. Exit that, go to extrude, take those two here, give that a value of 122 as a new solid, make that hollow, removing that face, give that a value of 4, and make that sketch visible again, make an extrude of that sleeve here, adding to the cylinder, give that 4 millimeters, call that cylinder, and give that type of appearance. Start the next sketch on that top face here, offsetting that edge with a value of 12 and projecting that edge, and then just make an extrude, adding to our cylinder, going down 6 millimeters, and just make a feature pattern. Well, that last one for the direction, I just pick that top face, turn that around, reapply features, distance is 12, instance count 6 or 9, huh? Accept that. Okay, so all this I will include in a folder with that name, cylinder. Now let's define a plane with a plane point, this one, and I just pick any face like this one here, so it's an offset of that plane through that point. And the rest of the pieces will be modeling here on that plane. We can hide that. And I think it will be convenient to work in the section view with that plane selected. Okay, so now I project. Well, first I gotta start a sketch on that plane and project edges, and then take that 2-point rectangle tool and attach that to those projected lines here. So that's going to be our piston, right? So I'll give that a value of 38 and a top distance for the combustion of 12, then a straight line through from midpoint to midpoint for the revolve of that one, and just a circle here with a value 10 millimeters, and distance here of 8. Okay, so I'll exit that. I go into the revolve, take that face and that one, a new body around that axis, a new body, yeah. Then again, just a shell, 4 millimeters is fine. Take that bottom one, and then let's extrude that pin. I'll just make that one piece to simplify things a little. So those two regions, adding to our cylinder, and I'll make that up to next, and take that second end position just as well up to next. All right, so let's rename that piston and change the appearance of that to that color. So we get those 3 here, those 4, and let's call those then piston. So let's start the next sketch on that very same plane. I'll project that cylinder and that hole, and just make a vertical line between those centers, make that a construction geometry, and let's work here on the bottom, and that'll be for the crankshaft, including the flywheel. Again, I simplified things by combining those two in one piece. So I'll start with a circle here, make that equal in size to that one, and give that vertical distance 32. Then I will take that center point arc command here, take that center here, first draw it like this, and give that a dimension of 68. Here, let's have a look at that, like right up, yep. Then a vertical constraint to that point, that one. Then a line going up here, over there. Then a tangent arc, connect that here. Make that center coincident here. Give that an angular value of 26. And pull that out here. Then here an offset distance of 6. go to mirror, take that mirror line and mirror those parts over there. I exit the sketch and just rename that crankshaft with fly wheel. We need one more sketch on that very same plane, and project that circle into that sketch, and again that cylinder here. So we got that circle here and that one. And just to eliminate confusion about it, I'll hide that sketch. Now let's draw that polygon, and that'll be with this as its circle 5 times. Make one line here with a horizontal constraint. Give that a dimension of 52. And then draw one circle here. Value is 10. Vertically aligned here with a distance to that line of 6 millimeters. Then draw a line from that center down here, and go to that that slot command here. Take that line and give that, where is the value for that? That's the 10 here. Just change that little to 18. And exit the sketch. Go into the extrude. Take that region and that one as a new body with the symmetric positioning and a depth of 6 millimeters. Accept that. Let's exit the section view for a moment. So there is our, well, the connecting rod, right? And we will build the master rod from that one. So we need another instance of that. So I'll go to transform, copy part, translate by XYZ, take that one, and just place it somewhere. Okay, so we got this one and that one. So which one is which? The last one is the one we pulled out, so I'll call that connecting rod. And now let's work here on that part. And I'll go back to my section view. Make that sketch. Well, I can rename that as well. rod sketch visible. And let's make another extrude, and that'll be this face. And well, let's hide that part for a moment. And that face. And that will be adding to that very part. And I will work with the now starting offset defined by entity, and I'll just take the back face of this, turning that around and giving that a value of 6, and accept that. We do need one more extrusion of that circle, and that goes 3 millimeters to the outside. So that is where that rod ends, and the second end position is that 3 millimeter plus that 6, so that's 9. Accept that. And now let's hide that sketch and make a circular pattern of that of that feature, that extrusion of that pin around that axis. Make that 5 times. Reapply features again, that option. And those are the pins where we will connect the rods. I accept that. Then I'll rename this part here master rod, and well, we can hide it for a moment and make that crankshaft with the flywheel sketch visible. There it is. We can hide that sketch. And that one. So let's extrude that face with a value of 8 millimeters. As a new body. Let's call that crankshaft. Crankshaft with fly wheel. Change the appearance of that to this one here. Continue extruding of that face with a value of 18, and one last extrusion of that circle. Turn that around, give that a value of 112, adding to our crankshaft with wheel. Okay, with a starting offset from our okay, we need to see that face really, so I'll exit the the section view, and there it is. Okay, so now we get everything modeled. I might change the appearance of the connecting rod and the master rod to a little darker color here. And we can hide that sketch. And that is all we really need in terms of modeling. Okay, so now let's switch to our assembly tab and insert the whole part studio here. And just I'll pull things to the back to a waiting position. And just take that crankcase and fix it. Then I'll take the fastened mate and position that first cylinder here. I will go into section view again here. And take the slider mate, pick that face, and that one. Then go to the revolute, and from our master rod, pick that central mate here. There it is. Pressing shift, you can get some help for the selection, and take that one. Okay. Now, again with the revolute, take that edge and take that one. And here we will just take a cylindrical mate between that edge and that one. Right, things are in position. I exit that, and now I will make a assembly circular pattern of that cylinder with that face as for the axis. Well, I'll make that 5 times. There you have that. And now let's copy and paste that a couple of times here. And apply that slider mate here and here. And there and there. Then here and here. No. Made connector of piston. I got that. And I wanted that. Yeah. One last time here. And there. Okay. Now we need 4 times that connecting rod. So let's apply that with a revolute. So I take that face, and that edge, and that one. I'll continue for the 4 of those. Here, that edge and that one. Okay, one more time for that revolute of that mate connector with that one. And now we just need to connect the connecting rods to the pins. I'll do that with a cylindrical mate. Start here. Take that edge and that one. It solves. No problem. No issue. That one with that one. Right here. And there. And one final one right here. And there. Okay. So that's it. We can move things the way they're supposed to move, to rotate, or we can pick that cylindrical mate here, the one that connects the shaft to the crankcase, and go to Animate, take the circular motion, go to Loop, make that a little faster, go to Play, and there it is, our radial engine moving. While that is in section view, sure, we can turn that off and go to that circular pattern, make that transparent to have a better view of what's going on. Well, I hope you liked this video, and I see you in the next one.